Good morning, everyone. Today, I'm going to present a use case with Apache Airflow and Cloud Composer. The goal of this video is to show to the community a real-world use case to catch the error in Apache Airflow and also Cloud Composer, because sometimes some developers can propose to repeat the error handling and the code in several DAGs. And in this case, the problem is we pollute the code with this kind of logic, and this kind of logic is error prone. And that's why I wanted in this use case to show a different approach with Apache Airflow. We can, for example, add some interceptors and callback for our errors occurred in our DAGs. Apache Airflow proposes to a native system to invoke this callback when errors occurs in our DAGs. And what is interesting with this kind of logic is we use a separation of concern principle. Instead of repeat the error code in several DAGs, we centralize this logic in one place in our interceptor and callback, and we only need then to add these parameters in our DAG configurations, and automatically Apache Airflow will invoke this callback, and in this callback we can then apply some error handling logic, like write some logs in Cloud Login, and also in this example we will ingest the current exception and failure in a BigQuery table. And this way to organize and manage the error handling with our DAGs in Apache Airflow is very efficient and very interesting. Some words about me. My name is Mazloum Tosun. I am a Google developer expert in Google Cloud and also head of Data and Cloud at Group Biz, that is a freelancer group in France. All these videos are proposed in my YouTube channel. I help the Google Cloud community with content on Google Cloud with many topics like best practices, architecture, data architecture, best practices, and so on. And also all the code proposed in these videos are proposed in my GitHub account. I am also active in social networks like X and LinkedIn, and you can feel free to subscribe and follow me in these social networks. I will show the schema of this use case. The CI/CD part is done with Cloud Build, that is a serverless tool for CI/CD in Google Cloud. The advantage of Cloud Build is a lightweight tool and also serverless tool. We will create 2 manual jobs with Cloud Build, and the first manual job will create a log-based metric in Google Cloud. We will use cloud monitoring because, as I explained previously, in our schema, we will intercept all the errors and failures occurred in our DAGs. And in the failure callback, we will write the current error and exception in Cloud Login and also in a BigQuery table. And when we will write the element in Cloud Login, we can intercept this element via cloud monitoring, for example. And to be able to do that with cloud monitoring, we have to create a log-based metric, firstly. This metric will apply a filter in Cloud Login in our log pattern, and we will intercept our log. And in this case, we will then create an alerting policy. This policy will target on the log-based metric created previously. And when an error will be written in Cloud Login, the alerting will trigger an email in real time. We have different possibilities for alerting. We can use, for example, messages, email, Slack, and so on. But in this use case, I choose to use an email, and we will see that our email will arrive and will be triggered in real time. After created the log-based metric and alerting policy with Terraform, we will deploy our DAGs with Cloud Build in Cloud Composer. Cloud Composer is a managed service that contains Apache Airflow in Google Cloud, and everything is hosted in a GitHub repository. For the application part, as I explained, we will propose 2 DAGs, and we will simulate 2 errors. One error to simulate an error with BigQuery, and another error to check if a required input parameter will be present and proposed in the DAG. When an error occurs, it will trigger automatically a failure callback. This system is proposed natively for Apache Airflow. And in our failure callback, we will retrieve the current error and the current exception. And we will prepare an object called failure. And we will write this failure in a BigQuery table. And then we will write a log pattern in Cloud Login and also the failure object. After writing this log pattern in Cloud Login, we can intercept it with the log-based metric and also trigger an email in real time via the alerting policy. Cloud Monitoring will intercept the log with our pattern in Cloud Login and send the email in real time. Cloud Composer manages the Airflow in this use case, and at the end of the use case, we will also visualize our errors in a Looker Studio dashboard. This Looker Studio dashboard targets on the failure table from BigQuery, and it's okay. I will jump on the code. For the code, I will show firstly the Terraform part. For the Terraform code, we have this variable project ID and also the Terraform resources. We will firstly create the BigQuery table. This table is called DAG failure. We will also propose a clustering in some fields to have some optimization where we will apply some SQL queries. We will also have an ingestion date in our table and propose a partitioning on day on this field because we will prevent to have some full scan in our BigQuery table. I show also the schema of the table. We have the DAG ID, the task ID, the current DAG operator proposed concerned by the error, the current exception name, the traceback of the exception. We will also propose and retrieve the current URL of the log. And we will also, from this column, we can access to the Airflow web server page that will give us the current DAG error. We also have our ingestion date, and we can apply a partition on this date. After created the BigQuery table concerned by the monitoring, I need to create a notification channel. Because as I explained previously, we can create some channels for our alerting in real time, and I choose to use an email in this example. The best practice here is to use a Google group instead of a nominative email. Instead to have mazlumtosun.groupbiz.ifr is interesting also instead to use a group email with several people inside, and we can manage more easily the people and remove an element or add an element if needed. But for simplicity here, I choose a single email. Firstly, I need to create a log-based metric in my example. And in Google Cloud, in Cloud Monitoring, we have a log entry payload that is a standard object proposed for Cloud Login. We can apply a filter on the severity. The severity here is error. We can also add a filter on the resource type. In this example, the resource is a Cloud Composer environment. And we can apply a text payload to filter the current error written by the DAG interceptor. I will show a little bit the log written by the interceptor. In the interceptor, I write this error with this pattern, and we can apply a filter on this message. It's perfect here for the explanation. I then need to bring an unicity for my current metric. My current metric is driven by the task ID and also the execution date of the task. In this case, I can also add a label extractor and extract the task ID and the execution date. And all the time, an error will occur in a current task for an execution date. The metric will be incremented, and in this case, we can trigger our alerting in real time. It's really important to add an unicity for our metric. And in this case, I choose to add the unicity with labels and the extractor. After this, I have a Terraform resource to create the alerting policy. I have a dependency with Terraform because I want firstly to create the notification channel and also the log-based metric in the correct order, and after this create the alerting policy in the correct order and after the twice and the previous resources. In this case, I have a display name for my alerting policy. I also need to pass some conditions, and for the conditions, I only need to give I only need to target in the previous log-based metric created previously. And I have the syntax logging Google APIs, users, and also the names of the log-based metric. And I will again pass the resource type with Cloud Composer environment. In this case, my alerting is linked in the previous login metric. And I need to pass then a threshold value. And for the threshold value, if my metric is incremented, in this case, my alerting will trigger and fire the email in real time. I can also pass a documentation. This documentation will be proposed in the alerting and also in the email. And in my case, the notification channel is an email, and with Terraform, we can target on the previous resource. And the syntax here is to use the resource name with Terraform and the resource concerned by the notification channel, and also the resource name and access to the name. I think it's okay for the logic of the Terraform part. I will jump on the Apache Airflow and DAG part. I have this root folder called error handling. And in this case, as I explained previously, I created 2 DAGs. One DAG will simulate an error with BigQuery. In this case, I target on a non-existing element in BigQuery. And in this case, the SQL query will fail in BigQuery and will indicate me that this element doesn't exist. And in this case, with Apache Airflow, I have this syntax to instantiate the DAG. And I can also propose some default arguments. In the default arguments, I will pass some elements that related to my DAG. And here I can propose my failure callback. I target to this method on the failure callback and access to the current context. With this method proposed natively by Apache Airflow, I can access to the current context for my task and for the failure callback, and access to the current exception. I then generate an object called failure info. In this case, I have all the needed fields like the DAG ID, the task ID, the operator, and also the element for the exception, and also the log URL and the ingestion date, as I explained previously. I prepared this object, and then I write with this log pattern in Cloud Login or in failure DAG managed by the failure callback. I also log the failure info because it's interesting to have this element in Cloud Login. I prepare the BigQuery Python client, and with this method, I can ingest my previous dict in the BigQuery table. My BigQuery table is called DAG failure here, and I can also apply some logic to retrieve the exception name from the exception given by Airflow. The exception can be a Python exception. For a Python exception, the parent exception is base exception, and it also can be a string. I check if the instance is base exception and retrieve the exception or a default exception name. And for the traceback, I apply the same kind of logic. If is a based exception, I retrieve the traceback and format the exception as a string, or retrieve directly the string given by Apache Airflow. I have all my logic here, and I write the result to BigQuery. It's really perfect. And I have my second DAG here. For the second DAG, I will check with the Python operator if an input param, because with Apache Airflow we can pass some input parameters at runtime. And in this case, with DAG_run_conf, I can retrieve the current input parameter, and if this parameter is none or empty, I throw and raise a value error exception, and in this case, it will invoke the current callback and apply the logic for my DAG. Also, an aspect that is interesting, if I create another DAG, it's not mandatory to use the interceptor. If for any reason I don't want to apply the failure callback for any DAGs, I can. I only need to pass default args without the on-failure callback. We have the flexibility to use it or not, but what is interesting, the element is centralized in the callback and no need to repeat the error handling and the technical code for managed our Airflow error. I think it's good. I proposed also the code for the DAG. I show the logic for Terraform in the CI/CD part with Cloud Build. We will trigger the Terraform part with Terragrunt, and we can pass some environment variables to Cloud Build. Also an element for the DAG. I have this Cloud Build job. I will deploy a setup PY file in Cloud Composer. I need to have a setup PY file to use a Python module for my Cloud Composer bucket. And also, I have this script to deploy this DAG folder containing all my Python logic and all my DAG logics. I think it's perfect. In my README file, I have some command lines to deploy my Airflow DAG and also the Terraform part. I deployed them previously, and to save time, I will directly jump in the firstly in BigQuery. In BigQuery, I have my table, my DAG failure table. I have all the fields that I showed previously for the task ID and the DAG ID and the operator exception and so on. And also an element for Cloud Composer. I have this main page for Cloud Composer. I can access to the web server for Apache Airflow, and I can also propose the DAG folder. The DAG folder contains all my elements copied previously by the CI/CD part. I deployed this folder error handling. I access to the web server in Apache Airflow, and I will trigger my DAGs and simulate the errors. I click here to trigger the DAG with BQ error and access to the DAG. And for the DAG, I click on the DAG ID. I can access also in the graph of my DAG. For the graph, my element is failed. I click on the element. I can also access to the log. For the log, I have my log pattern, error in Apache Airflow managed by the failure callback, and it's perfect. The error was thrown and raised as expected by the callback. And if I access to my BigQuery table in the preview, I can refresh my table. And normally, a line was ingested as expected in my BigQuery table. I have my DAG ID, my task ID, the current operator, a BigQuery insert job operator. The current exception name is a bad request in this case. I have also access to the exception traceback. And in the log URI. For the log URI, I can copy my element here and access to the log from the Apache Airflow web server. And it's perfect. And the element was ingested now. The format is UTC, but it corresponds to our line. I will then execute the second DAG and access to the main page. I click on this button and trigger the second DAG with the required input parameter. I click on the DAG ID and access to the graph, and my element is indicated with an error. I access to the log, and we have the expected error here. We have our main error message here, and also the error, the current error. It's a value error with the required input param is missing. I access again to BigQuery, I refresh my table, and I have the line concerning the second DAG, and also in this case the Python operator. The task ID is validate input param. I also have the current exception, the traceback, and so on. It's really perfect. I simulated the error, and normally I will access also to the email to check if my email arrive in real time. I have some lags with my email, but I think it's perfect. I received the first email here in real time, triggered by the alerting policy. In this case, I have some elements like the current project and also the condition, also the documentation, and I can also access to the current log in Cloud Login. I have the filter passed by the Terraform part and by Cloud Monitoring, and access to the current error in Cloud Login. I have the traceback here, and as expected, and it's perfect. I can also access to the incident because when an alerting is triggered by Cloud Monitoring, we consider that there is an incident in this case. Okay, I will then, I have my second alerting in this case. I access to the log, and I can see that I have my second error here with the Python operator. I think it's perfect. We presented all the elements. It remains, the Looker Studio dashboard. I access here. I created a Looker Studio dashboard, and in this case, I added the schema in the Looker Studio dashboard. And in this case, we target on the BigQuery table, and we can visualize all the needed elements from a dashboard. And it's interesting because sometimes we can expose this dashboard to our partners like the Run team or other. And in this case, I also added a default filter in the current date in order to have the errors concerning the current day and use the current partition to optimize the cost and then the users can change the date if needed. I will refresh my dashboard, and we can see the new errors here with the DAG operator and so on. I can also show you a little bit the screen for cloud monitoring. And in cloud monitoring, normally, we have access to all the elements. We have access to the metric, log-based metric. And in log-based metric, I have my composer DAG task error, and is really perfect. We can access to our metric here in Google Cloud. And we can also access to the alerting policies in Google Cloud. And we can check all the incidents and access also to our alerting. I think it's good. We presented all the elements, the CI/CD part with Cloud Build, and we created the log-based metric and the alerting policy with Terraform and Cloud Monitoring. We deployed the DAG in Cloud Composer bucket. We simulated the errors in 𝐞_DAGs, and in this case, the failure callback is invoked, and in this case, we write the failure in BigQuery and also in Cloud Login. The cloud monitoring in this case can intercept the log from Cloud Login via our pattern error message. And in this case, after the metric is retrieved in Cloud Login, the alerting policy will trigger and send an email in real time by email. And at the end of this use case, we visualized our failure data in a Looker Studio dashboard. It was a pleasure for me to present this video to the community. Feel free to subscribe to our YouTube channel to help our work for the Google Cloud community, and see you soon. Bye bye.